Hey, what's up, everybody? Welcome to the stream today. We've got a great one planned for you guys. We're gonna jump straight into the action, though. We've got some friends from DataRobot here. I'm gonna kick it over to Zach to show a sweet demo to get us kicked off for today. Zach, take it away.
Awesome. Thanks, Chris. So welcome, everyone. My name is Zach Ingbertson. I'm a technical field lead at DataRobot. Today, we are going to be going through two demos. We'll do one demo, we'll break for questions, and then we'll do another demo, more questions. And what we'll be going over is how we can use NVIDIA-powered frameworks and models in DataRobot, how we can optimize across those architectures with evaluations, and we have an open source package called syftr, which I'll tell you a little bit more about, how we can actually orchestrate these workloads backed by GPU acceleration, how we can debug and optimize these pipelines and then monitor them, and then how we can also add guardrails and tracing and compliance over the top. So without any further ado, we'll jump into the platform. For anybody who hasn't seen DataRobot before, this is in what we call our playground, and this is specifically an agentic workflow playground where we can bring in agents and we can ask questions. We can ask a question, get a response from them. Then we can also compare across agents. So over here, we have a view of 3 different agents that we've built and we've compared. So we've run some evaluation metrics across them. First one is just a very simple linear llama-based model. It is, kind of the entry-level model. You bring it in, you give it some tools, and then you just have it go. Middle one over here, this is a Nemotron model. This is a Llama 3.3 Nemotron Super 49B V1 agent in a React framework with some of the same tools. And then over on the right side, it's that same Nemotron Super model, but it is with a multi-agent setup behind the scenes. So it's kind of orchestrated so that we have multiple agents working together.
Zach, before you go on any further, do you mind just
Absolutely.
punching me in a couple pips of zoom on your screen there
Oh,
so the text is a
absolutely.
little bit bigger for us? Thanks so
Sure.
much, man. Sorry,
Yeah,
sorry about that. Go ahead.
all good. I'll collapse that over there too. So, uh, obviously, when you're working with LLMs or with agents, you can go through and you can read them. You can read the responses. You can ask your questions and read the responses. So the subjective experience is important, but we want to go beyond the subjective and we want to actually get some evaluation metrics. So what DataRobot lets you do is you can run evaluation data sets, and we have different evaluation metrics and criteria that you can use. So we can actually say, how well is this agent performing on a more quantitative basis? So we can zoom in a little bit over here, and you can see we have our agent goal accuracy, and we have task adherence here. So this the React agent is getting the right answer, but it's also including some extra information. It's not staying exactly to the task that was set for it. But with this multi-agent setup, you can see we have still high accuracy, but it's much greater task adherence. So this really lets you get in and see not just, okay, I'm reading through and seeing how do I think these agents are doing. We can get actual metrics to say which one should we prefer, all else being equal. Uh, so this is one way that we help evaluate and compare across models. To actually figure out what's going on behind the scenes, we can even click into a model. Oh, there we go. So now we're just looking at the specific responses from this multi-agent model, and we can go into the tracing table here. And so this is all still in the development process. We haven't deployed this out. You just get this tracing out of the box with DataRobot. So when you're running these through the playground and getting these evaluation metrics, you can actually see every step the model is taking, what tools are being used, and then you can click in on any of these. So if we click in here, you can see this tool is actually calling a DataRobot predictive model. It's calling a time series model because we can wrap we have a long history of building predictive models on DataRobot. So you can wrap your predictive models classification or time series as tools, and those can be used by these models. And so then in the tracing table, you can see what were the inputs? So this is looking for butter forecast demands for Phoenix, Arizona, and then we give the response back to the model. So this lets you get kind of deeper inside one model to see what's actually going on, and is it doing the things that we expect it to do. We also have additional evaluation metrics for were the tools that it used the right tools for the job. So this now brings up, I mentioned syftr in the introduction, because right now we've just gone through 3 examples. We went through, one simple one, one medium, and one more complex one, but there's a lot of other variables in there. Yep. So syftr is one of our open source libraries that we've released. It's available on PyPI, and I believe the GitHub link will be in the resources as well. But essentially what this lets you do is it lets you automate the comparison across many different combinations. We try to automate different models with different retrieval techniques and different tools and embedding models, because there are so many different combinations that you could encounter that to manually hand code them all and then manually compare them would be an exhausting process. So what we're seeing here, this is the Pareto frontier. So we're plotting cost against accuracy. So we can see what are the best combinations of things if you're trying to optimize for accuracy at a particular price point. So you can essentially ignore all of the gray dots because either for a particular price, they perform worse, or for a particular accuracy, they cost more. So if you're just looking at the frontier over here, you can see, okay, well, we've got some nice Nemotron supermodels with different settings over here that we can recommend what are the best combinations of things to use. Okay. So we have gone through those. We are going to jump over to, so we've mentioned Nemotron Super. How do we actually use those in practice? How do we get you access to these models? Well, NVIDIA has partnered with us, and we have this NVIDIA NGC, the NVIDIA GPU Cloud gallery that is accessible directly through DataRobot. So we can search. If we search for NEMO models, we can come in and we can see we have our nice Jensen there. We have our Llama 3.3 Nemotron Super 49 BV1, and I'm losing my breath saying it, but it's a good model. What we can do is we can click next, and now we pre-configure this to automatically spin it up on DataRobot. So we have a ton of models out of the box. It's not just generative models, not just agents. We have lots of different kinds of workflows that NVIDIA has provided that you can then wire together along with your generative models and your tools and your other agents, and we can connect those together. And basically one-click deploy, and now you have a model that you can use. So I'll pause here. So that was demo 1. We can pause.
Awesome.
We'll go through.
Awesome stuff, Zach. Yeah. So, guys, excellent first demo. We'll get to some introductions now that we've seen kind of the way this whole thing works. Everything from the evaluation, the tracing, to syftr. So my name is Chris. Pleasure to be here with you guys today. We're joined by DataRobot. Zach, thank you so much for that first demo. That was awesome. And like Zach said, we're gonna take a little pause to do a little bit of yapping. Okay, we gotta do some talking about Nemotron. We heard that name come up a few times, so we're gonna get a slide up here and just give you guys a brief rundown of what that means, and then we'll get some questions about Zach's first demo and any questions you guys have about DataRobot's awesome tech. So what is NVIDIA Nemotron? Well, NVIDIA Nemotron is our open models. So this is the idea that we're creating models that are meant to be inordinately open, right? So more open than is typical. This is everything from the recipe provided through technical reports all the way to the data, the post-training data, including some pre-training data, right? And the idea is we have a couple ways that we can create Nemotron models. And one of the ways we've done it in the past, like you just saw with DataRobot's Llama Nemotron Super, is taking a leading open frontier model, like back in the day, that was, of course, Llama 3.3. And then doing all of this stuff, right? So there's a bunch of steps here that our incredible research teams leverage to take that model and then produce from it a NVIDIA Nemotron model. So that goes through NAS, neural architecture search, distillation, do some training, do some data curation, do some SFT, RLVR, make sure it's safe, make sure it's ready for long context, all of this stuff, everything we do in order to produce that final NVIDIA Nemotron model. And so that's the idea of that Nemotron series. That's what you're seeing when you hear Zach talk about the Llama Nemotron Super model. Is this process? This is something that we love to do. We're going to keep doing, and we're excited to see where else it can plug in. That's enough of the yapping about Nemotron. Okay, so hopefully you get the idea. They're good models. They're open. Give them a try. They're linked in the chat, and we'll move on to some questions. I see we have a few in the chat, so let's get those up on the screen. And Zach, we'll see if you've got some sweet answers. So first question from Luca: AI agents are only as good as the data they can access. How are you seeing organizations handle data that's scattered across multiple clouds, on-prem, and even classified systems? AI agents are only as good as the data they can access. I see. There's a double. We've doubled down. So how does this work when we need to connect our agents to these very disparate spread sources of data?
Yeah, I mean, that's a great question. So in order to get access to data, we need to make sure that you are the right person to be able to access that data. So we are in our the way we orchestrate everything, we're able to pass, we can pass tokens. So if you have SSO tokens or other credentials, we can pass those along with requests so that the tools on the back end can get access to only the information that user, the one that's making the request, should have access to. And I think this is a good call out for why having kind of a platform agnostic orchestrator is is kind of the safer play here, because every company has their own, like, this is our agent that you can use to access our data and our resources, but that doesn't connect to everything else that you use. So having some orchestrator that can kind of sit in the middle and have access, and networking is always hard. I'm not going to lie, if you're on-prem, just connecting things together, networking's over my head. But as long as you can have network connectivity and as long as you can do the authentication, having something like DataRobot that can sit in the middle and connect with all those different disparate data sources, that can really be the integration point for pulling things together.
Yeah, awesome. And do you guys have any kind of unified data connectors or anything like that, Zach, that might be helpful here? And what do you find DataRobot people? Are they on-prem? Are they in the cloud?
Yeah, so DataRobot's been around since about 2012, and we've had the chance to. Our background is in predictive models, and so we connect to all sorts of distributed systems. We connect to blob storage and relational databases and lots of data kind of historically used for predictive models. But then we also have OAuth connectors, so we can connect. So if you authenticate with Google, we can kind of broker that through the platform to be able to connect you to your data without having to code in that OAuth flow into every app or agent that you develop. So we're able to just connect a lot of things out of the box, and then we provide you the tools to additionally connect to further data sources as well.
And you guys have a lot of people on-prem that work with you guys?
We do. I would have to ask about the specific breakdown, but I think it's probably about 30 to 40% on-prem, either on-prem or in private clouds, and then the rest are using our multi-tenant. So it's a pretty decent split between people who are using us in our multi-tenant environment versus kind of hosting us in either on location or in their private clouds.
So it sounds like, I mean, it's a hard problem, but hey, if they want to get started, sounds like there's the right place to go. We'll get the next question then.
Oh, and to correction, I'm told that about half our customer base is on-prem. I got that message on the side.
That's not bad. That's not bad. And this is being recorded, guys. So this is going to be available on YouTube afterwards. If you want to come back, watch the recording, and anything you missed, it'll be here. Great question from Williams. What is the purpose of DataRobot? It's kind of a broad one, so take it how you will. But what's the purpose of DataRobot?
Sure. So this is a great place to pull in our DataRobot introduction. So DataRobot is an end-to-end agentic AI platform, and we've been delivering AI solutions for businesses and customers since 2012, as I mentioned before. We have customers in pretty much every vertical and every horizontal. We've patented over 70 innovations in both the predictive and the agentic space. So our goal is to try to let you bring your agents and your data to the platform, integrate everything, let you evaluate it, test it, deploy it out. So the next stage, the next demo, will be actually deploying things out into production and monitoring them there, and then wrapping the guardrails around them. So once you're done with the build and experimentation phase, you can actually deploy them out, and now you have an endpoint, and you can have things networked together, MCP servers, agents, tools, all being hosted in the platform with all of the monitoring wrapped around that and the governance. So you can track as you change your agent code and your models, what changes are happening, and then you can correlate that with what were the performance impacts of that, or what impact did this have on our KPIs after we made these model changes. So really, it is an end-to-end platform for being able to experiment, deploy, and then actually monitor and govern these over time.
Incredible. It's like you're set up to do the intro.
Yeah.
We had a question actually about MCP, and I just heard you mention it. So maybe we'll take that before we jump into the second demo here. So can one use MCP server to make data access on multiple systems easier? Is this something you guys are seeing as a useful pattern?
Yeah. So I would say that one of the biggest benefits of MCP is making things reusable, because if it's all running from the same place, accessing the data would essentially be the same if you're doing it directly from the agent versus if you're doing it from the MCP server. But putting things into an MCP server lets you have kind of a registry of tools. And we do have a DataRobot MCP server example, which shows how you can actually make predictions against DataRobot deployments, and how you can access data sets and just kind of automate a whole lot of things on DataRobot itself. But for all of your the customers out there, you be able to bring your own tools and then benefit from the tools that come out of the box. So I would say that the reusability aspect is a really big one from MCP, because you can, if you can have one place where you can connect to your data, you can set up the credentials and configuration there, and then you can just reuse that across multiple agents.
Incredible stuff. Guys, we're going to jump into the second demo. Please keep filling the chat up with questions. We're going to continue to answer questions after the second demo, or any that come up during that are relevant. So keep slamming that chat. And Zach, take us away to the second demo. It sounds dope. We're talking about going into production, right? So
all right. So we'll switch back over to DataRobot. So I mentioned before, when we are in the playground, so the metrics that you saw before, the evaluation metrics, the task accuracy, task adherence, those are things that we can configure in the playground. So as we are developing these and evaluating the models, we can get these metrics so that we can decide which model we want to deploy. Once we actually do deploy it, so here we're looking at, this is a deployment, and in DataRobot speak, a deployment is essentially a Kubernetes pod that is running your code, or pods plural. But we give you an endpoint, we automatically instrument it with monitoring metrics, and we track all of the metadata and the governance and who has done what and when. So it's basically a container to track all of the information related to the particular agent or vector database or tool. So we can come in and we can see usage metrics of this particular deployment, how many requests have been coming in. We can track the system health. But then we can also get those same metrics that we configured earlier during our evaluation. We can then get those metrics over time. So we can see, and this is zoomed in quite a bit, but hopefully you can see like here, our task adherence guard latency. We're continuously running that task adherence metric. So we're able to see over time how it's performing. Do we get better accuracy over time, worse accuracy over time? Is it performing just as well as we would expect, both from the accuracy perspective and from the speed perspective as well. So these metrics allow you to continue on everything that you did in the eval period all the way through, your day 90 when it's deployed out, and you want to be making sure that everything is working as expected going into the future. And so a lot of these come out of the box, but you can also bring your own metrics as well. So if you have particular KPIs or particular metrics that you specifically want to monitor over time, you can bring those in. And as long as you can write them in code, then we can run those kind of asynchronously in the background and then track those things over time. And I will pull back just for 1 second. And you can see, so I mentioned our deployments are kind of containers for all of these different kinds of services. So we have the ability to monitor in the same way vector databases and NIMs and guard models and our agentic workflows. So this really gives you one place that you can look to be able to see how these things are performing over time. And additionally, I will say, I've been doing everything through the GUI so far. Pretty much everything that you can do in the GUI in DataRobot, you can also do programmatically. And I think we have a very technical audience here today, so I don't want you to think that you have to do everything clicking through the GUI. You can orchestrate pretty much everything through code, which is actually how we have our agent templates set up. So we can actually jump over to here. So this is an example. So this is just locally, I have an example agent template that I spun up here. We're using Pulumi behind the scenes to do infrastructure as code. So this lets us do something like, if we have, pull this over. If we wanted to make a change, so if we wanted to replace the Claude Sonnet with a Nemotron Super, I just save that file. And now we can just do, with one single command, we can do task deploy. And this will actually figure out what is the minimal difference it needs to apply in order to bring that change up into the environment. So you can see here, it's only changing 3 out of my resources, and 4 others are remaining unchanged. So for the developer experience, we're really hoping that this is going to make it easier for you to go in and experiment. And as you make your modifications, you don't have to wait for everything to rebuild and redeploy out. You can make these kind of more precise modifications to your agents. And then everything gets tracked and governed up in the platform. So we'll jump over, and I think I'll do 1 more minute so we leave time for questions at the end. For kind of compliance purposes, risk and compliance purposes, we can run compliance tests on, so in this eval period, before you actually deploy something out, we can see how well your agents are doing on different benchmarks. We have out of the box ones, you can bring your own. So this one failed on how it was responding if people sent in personally identifiable information. Everything that you do here also gets carried through to the registered model. So I mentioned that we are also a governance platform. So all of the tests that you ran with no extra effort on your part, those can get bundled into a compliance documentation. So we can jump in here, and then we can see in our system evaluation, we can see those metrics that we ran when we were testing it in the playground, those automatically flow through and get associated with our model, which then when we deploy out gets linked to that. So everything is together in one place. And it makes it really easy to be able to know what was deployed, when, how did it perform, who did it, and then be able to trace that all the way back. So is that 25 past? So I will stop here and we can open up for questions. And
Incredible demo. Yeah, I mean, it strikes me that there's just, thank you for these two incredible demos. I imagine you could do many, many demos. Seems like there's a lot of depth here that we're just getting into. And guys, we've been spamming the comments with links to different resources that you can check out. Dive a little bit deeper into what DataRobot's got going on. But we'll take some questions now to kind of spend the rest of our time together. So we ask, can this also work with smaller models like SLMs?
Mm-hmm. Yeah, so I guess it depends what you mean by could this also work. So yes, on a technical level, yes, you can bring SLMs, you can run them. If you want to run them on CPU, you can run them on CPU. You can bring your own models and run them on NVIDIA GPUs on DataRobot. So yes, you can bring small language models and run them. The performance is the thing that I would be most concerned about with that. So I think you would really want to go through and evaluate, are the gains that you get, or is the benefit from using the small language model enough to balance against whatever accuracy decrease you might get from using those language models. But in principle, yes, you can bring your own models, we can host them, we can proxy out to other models. So we are very flexible in terms of which models we can use and what we can connect to each other.
I mean, there you go. And guys, one of the things about small models too is like they offer a suite of benefits that are kind of, on a different axis than just say accuracy or capability, right? So something like, not to do the plug, but NVIDIA Nemotron Nano V2, right, which is a very efficient model, small model that's still capable at these kinds of agent tasks that you'd want it to be. I mean, this is something that can help you at different stages of like a agent pipeline. It seems like, and correct me if I'm wrong, Zach, but it seems like you could use DataRobot to kind of figure out where the best piece of the pipeline, Nano might fit into with something like syftr.
Yeah, if you wanted to use a nano model as some kind of router to figure out how to direct traffic, and then use another model for actually doing building some kind of report, yeah, that we can wire them together in all sorts of different ways.
You'll love to hear it. We'll go on to the next question. All right, the jump from POC to production AI agent reminds me of managing platforms that went from 3 weeks to 2 hours provisioning time. The architecture that works at small scale completely breaks at enterprise scale. What's the most counterintuitive architectural decision you've had to make when scaling AI agents from a demo to thousands of concurrent production instances? This is such a cool question.
Yeah. So yeah, I'll have to give that one a little bit of thought about what's the most counterintuitive. So while I'm thinking about that in a background process, one of the things that we can do in DataRobot is we have multiple ways of scaling up and down. So we can kind of horizontally and vertically scale all of our deployments. So going just on the purely technical level for scaling, that is something that you can do on the platform, and you can scale by CPU usage and number of requests, and we can kind of gracefully scale up and down. I guess in my opinion, one of the more difficult things with agents and these kind of more distributed systems is how you do have to think pretty carefully about what resources are being consumed where, because it's not necessarily that everything is running in the same container, right? We now have this container is talking to that container, which is talking to that server, which is doing that thing. So you may be able to, the requests coming through on that first contact point may have no issue routing things and handling things. But then if you have hundreds of requests coming in at the same time for doing, really significant database queries, you're just going to be pounding the database, and then that one component could be causing issues. So I think it's being able to kind of understand how things are mapped together and what computations are happening where, and then being able to spread the load out in those places. I'd say that is something that, as these systems become larger and more distributed, is something that you do have to consider.
Yeah, I mean, it's one of those things too, where I think, as you're building these more complicated agent systems, so you start to move into, multi-agent and all these other really fun words. I think something counterintuitive that I've seen is the kind of capability of model required is not necessarily, even as the complexity grows, like it doesn't grow very aggressively if you're designing a system that's very well kind of compartmentalized, right? So I think people have it in their brains like, oh, very complex agent, I'm going to have a very thinky model, right? And it just is often the case that you can get away with something a little bit snappier, which is not necessarily the intuition. But you guys are doing so much stuff. If you think of anything too, please let us know. We'll make sure to forward it on to the community. We'll take the next question now. Can we use graph databases as well? Neo4j or Apache Age? Great question.
So the answer, generally speaking, to can we use is yes, because we have certain things that are just kind of provisioned out of the box. So we have really easy ways of building out RAG pipelines. We can build a vector database using an in-memory vector database, or using your Elastic or Pinecone. For anything that we don't support out of the box, we have a very robust kind of bring your own strategy. So as long as the thing that you want to connect to has an endpoint that we can reach, we can connect to that and we can get data, and then we can wire it in the same ways. So we can essentially treat a graph database like a vector database, kind of on the platform, where query goes in and then citations and metadata come out, because it's kind of that is the same kind of contract as with just making a regular vector database call. So as long as we can connect to it, you can make your graph queries against it, and then you return your data, and then we can use it. I didn't show an example today, but in the playground, if you are using a vector database, we can show you what citations were returned for a particular query. So there are some nice things that are built in by using a vector database deployment type with a language model. And yeah, if you can conceptualize it as a vector database, then we can wrap that and bring it in, and then you get all the same benefits that you would out of one of the built-in ones.
Alrighty. We're gonna take a couple more questions before we close, guys. But before we get to those questions, I'm actually gonna ask our community team to bring up the slides to tell you how to keep in touch with us after the live stream is done. We want to keep the conversation going, keep working with you guys, keep hearing from you. So we'll get those slides up so we can tell you kind of what how you can stay connected outside of the stream here today. The big one is going to be our resources like our Discord. So you can go to our NVIDIA developer Discord. We have a couple of channels that you can go to. If you want to learn more about Nemotron models, of course, you can go to the hashtag Nemotron-models page. As well, if you want to look at our models, they're on Hugging Face, of course, under the NVIDIA org. And then we have, build.nvidia.com, where you can play with these models. This is, also powered by NGC catalog, similar to what Zach showed during the first demo. And so we'll take a couple more questions. And there's the Discord. Yes, discord.gg/NVIDIA developer. Come on down. Ask any questions that you have for us about this live stream or more. and email us directly if you should find yourself inclined to do that at community@nvidia.com. Zach, we're going to take a couple more questions and then we'll wrap this thing up. Guys, it's been great. Hey, look at this. We've got agents in the AM. I'll let you talk about this one.
Yep. So just a brief thing for DataRobot. We have a series called Agents in the AM that's going around. We have sessions coming up in Boston, New York, London, Dubai, Tokyo, and more. I believe you can scan the QR code to learn more. And yeah, space is limited. So if you are interested, check it out sooner rather than later.
That's right. It's going fast. Get in before it gets closed. Okay, we'll do 2 more questions, and then, guys, we're gonna wrap for the day. If we can get the next question up on the old screenerino here. All right, how to find more information about on-prem architecture? Is it 100% on-prem, or will it still have to have cloud dependencies?
Yeah, so we do have customers that run this in air-gapped systems. So that does add on some complexities because you can't just go out and install packages from PyPI. But if you have a locally hosted repository, we can point to that. We can point to local Docker registries. So yeah, we can run completely on-prem, but you don't have to. So we have the flexibility of being able to run DataRobot. We have our multi-tenant SaaS, which is a public website that you can go and access from there. So that is cloud hosted, cloud connected to everything. We also have single tenant SaaS where we can manage your own instance in a single tenant so that your data is isolated completely just inside your cloud framework of choice. Or if you have the ability to run Kubernetes applications, we can install on-prem in a variety of different backends. So yeah, we can let us know where you want to install it, and we can do it.
Sounds like if there's a will, there's a way with DataRobot. That's good news indeed. We'll go to our last question, guys, and then we will wrap it up. And this is a classic. What kind of out-of-the-box connectors are available for plug-and-play scenarios with DataRobot?
Yeah, so we have well, depends how you define connector. So we have a number of things that are built to be able to connect to outside resources. So I mentioned before, we have a ton of connectors for connecting to things in different clouds. Oh, and let me see if I can pull this up over here. So we have on our docs page, we have a list of all sorts of different connectors that we can connect to. A lot of these are for structured data, but as I mentioned before, we do also have the OAuth connectors for being able to connect to OAuth data. For vector databases, we have connectors for things like Elasticsearch and Pinecone. For LLMs, we can out of the box connect to a ton of different LLMs. So we have it's called our LLM gateway. So we can provision access to various LLMs from all of the major providers, in addition to being able to host your own. So I would encourage you to go and check out the docs, see if there's if the kind of connectors you're looking for are there, and if not, let us know, and we'll try to add them.
I'm hearing G Drive is available now. Is this correct?
Yep. So
and SharePoint's coming later this month. Is this correct?
Yep. That is correct.
Very cool. Very cool, guys. Thank you so much, everybody, for joining the stream today. Thank you so much, Zach, and all the DataRobot folks behind the scenes. Absolutely awesome to have you guys on the stream. If you're excited about this kind of stuff, if you're excited about agents, if you're excited about AI, let us. One more plug. Let's remind you about GTC DC coming up at the end of October in DC, surprisingly. And so we hope to see you guys there. DataRobot, thank you so much for coming out. This was such a blast. Please ask any questions you have of us. A QR code, there it is, QR code. Ask any questions you have in the Discord, forums, email, LinkedIn, whatever. We love chatting with you guys. Love having the community all together here, and enjoy the rest of your Thursday and then your weekends. All right, thanks, guys.
Thanks for having us, Chris.